Good morning, dear children. Welcome back to our online maths class. Okay, nowadays we have been learning about what? Fractions, isn't it? I think most of you, or rather all of you, are familiar with the concept fractions now. Are you familiar? Okay. And we have been discussing about the types of fractions, isn't it? And in that we had discussed proper fraction and improper fraction, isn't it? Now let's move on to the third type of fraction. Okay, while writing I shall explain. Okay, please start writing. As I have been saying always, mention date and day on the upper portion of the margin. Okay, third type of fractions are like fractions. Or together let us write like and unlike fractions. Any idea about this? Last year we have learned like and unlike fractions. Okay, let me explain. Fractions with same denominators are fractions with same denominator are known as like fractions. So let's write first. After that, it shall be explained. Okay. Fractions with write neatly. Okay. Same denominator. Fractions with same denominator are known as like fractions. So what is meant by like fractions? Fractions with same denominator are known as like fractions. So let's denote this by 1. Fractions with same denominator are known as like fractions. So can you say some examples of like fractions? Their denominator should be same. That's the only condition. So fraction with same denominator down, the numbers down should be the same. That's the condition for the fractions to be like fractions. So please try to say some examples of like fractions. Yes, all the denominators should be same. So 3 by 7, then 8 by 7, then 11 by 7, then 2 by 7, isn't it? Are they all like fractions? Yes. Can we write 8 by 9 here? No, why? Here denominator is 9, so it won't be a like fraction, isn't it? So have you understood? All these have the same denominator. What is the common denominator here? 7, isn't it? So these are known as like fractions. Etc. are like fractions. Got it? Yes, I think it's very easy, isn't it? Now let's move on to the second one. Unlike fractions. So what will be the unlike fractions? Can you say? We know the like fractions are the fractions with same denominator. So obviously what will be unlike fractions? Yes, fractions with different denominators are known as unlike fractions. That's all, isn't it? Okay, let's write. Fractions with different denominators are known as unlike fractions, isn't it? So just try to say some examples of unlike fractions yourself. Different denominators are known as unlike fractions. Can you say some examples of unlike fractions? The denominator should be different. So 3 by 8. Okay. Then next, can we write 4 by 8 here? No, same denominators cannot be same. So next, try to say something. Okay, 11 by 9, then 5 by 6, then 2 by 3, yes, good, etc. Which fractions? Yes, unlike, etc. are unlike fractions. Are you all writing neatly? Write neatly, okay. Unlike fractions. So, have you understood what is meant by like fractions and unlike fractions? Okay, these play a very significant role in adding and subtracting fractions. While taking those portions, it will be explained, okay. Now let's move on to the fifth one, and of course an important one. Okay, before that, just write, okay, fifth one is not that. Okay, write down fifth one, unit fractions. Fifth type of fractions is what? Yes, unit fractions. Any idea what will be unit fractions? Unit means what usually? Unit means 1, isn't it? Unit means 1. So what will be unit fractions? Yes, fractions with 1 as the numerator are known as unit fraction. Understood? That is, don't write after unit fractions heading, stop writing 1 by 6, 1 by 11, 1 by 13, 1 by 89, etc. etc. All these are what? Unit fractions. Got it? So what is the definition of unit fractions? Fractions with 1 as the numerator are known as unit fractions. Okay, shall we write? Okay, write down. Fractions with 1 as the numerator, fractions with 1 as the numerator are known as which fractions? Are known as unit fractions. Understood? Fractions with 1 as the numerator are known as unit fractions. 1 as the numerator. So let's write some examples. Okay, try to say some examples yourself. Okay, 1 by 25, then 1 by 9, then yes, 1 by 4, then 1 by 11, etc. Isn't it? Etc. are unit fractions. Unit fractions. Okay, you please complete. I have no space here. Okay, this much enough, etc. is enough. Okay, now move on to the sixth type of fraction. Okay, before start doing this, just listen carefully. Don't write after completing the unit fractions example. Stop writing and listen carefully. Very important concept is coming. That is, don't write, okay? Stop writing and listen carefully. Stop writing and listen. Okay, now please stop writing and listen carefully. Equivalent fractions. This is not meant for writing, just listen carefully. Equivalent fractions. Okay, I'm going to give some examples. So, observe these examples carefully. This is a rectangle. This is another rectangle this is another rectangle of same size. They are same size. And one more. Let me draw one more rectangle of the same size. Actually, I meant to draw the rectangles of same size, but I couldn't draw in this big screen properly. But you have to draw accurately. Okay. So here we have 3 rectangles of same size. That means same length and breadth. So here it has been divided into 4 equal parts. Here the rectangle has been divided into 2 equal parts, and in the third figure the same rectangle has been divided into 8 equal parts. And here in the first one, the shaded portion is this one. Okay, so can you say what is the fraction corresponding to the shaded portion? What is the fraction corresponding to the shaded portion? Yes. How many out of 4, how many are shaded? 2 are shaded. So fraction is 2 by 4, isn't it? Out of 4, how many parts are shaded? 2 are shaded. That means the fraction is 2 by 4. Here, this is the shaded portion. Yes, okay. Out of how much? Out of 2. The rectangle. The rectangle is divided into 2. The rectangle is divided into 2 among 2 portions. 1 is shaded. So fraction is 1 by 2. Isn't it good? And here the rectangle has been divided into 8 equal parts. Isn't it? Rectangle has been divided into 8 equal parts. Okay, in the beginning I told it as a triangle. No, rectangle itself, isn't it? Okay. If I had committed any mistake in the beginning, please correct it. Okay. Pardon me. This is rectangle. Okay. Yes, rectangle here. The rectangle has been divided into 8 equal parts. And so the denominator is 8. Isn't it? Out of 8 equal parts, how many are shaded? How many parts are shaded? 4 are shaded. So here in the first figure, out of 4, 2 are shaded. The second figure, out of 2, 1 is shaded. The third figure, out of 8, 4 are shaded. But actually, are they all represent the same portion of the rectangle? Isn't it? Here also the portion, the half portion of the rectangle. Here also exactly the half portion of the rectangle. In the third figure also, this fraction represents exactly the half portion of the rectangle. Isn't it? Isn't it? Yes. Here in this figure, in the first figure, the fraction 2 by 4 represents the half, exactly the half portion of the rectangle. Are you agree with me? Do you agree with me? Okay, do you agree with me? Okay. In the second figure also, the fraction 1 by 2 represents exactly the half portion of the rectangle. In the third figure also, the fraction 4 by 8 represents exactly the half portion of the rectangle. This means, and of course we know these 3 rectangles are of same size. That means, what can we conclude from this? From these figures, what can we conclude? Yes, we can conclude that the fractions 2 by 4, 1 by 2, 4 by 8 are equal. So from this we can conclude that the fractions 2 by 4, 1 by 2 and 4 by 8 are equal even if they look different. Understood? From these figures it is fairly clear that the fractions 2 by 4, 1 by 2, 4 by 8 are equal even if they seem to be different. On seeing the fractions, we may think that 2 by 4 is not equal to 1 by 2, that is not equal to 4 by 2. On seeing itself, just from the glance, we may think these fractions are different, but actually are they different? Are they different? No, they represent the same part of a whole, isn't it? They represent the same part of a whole means here the fraction 2 by 4 represents half portion of the whole. Here whole means WHOLE whole, the entire portion whole. In the second one, the fraction 1 by 2 represents the half portion of this whole rectangle. And in the third figure, 4 by 8, the fraction 4 by 8 represents the half portion of the entire rectangle. So, even if these fractions seem to be different, they are actually equal. Even if these fractions seem to be different, they are actually equal. Such fractions are known as equivalent fractions. Such fractions are known as equivalent fractions. Understood? Got some idea? Okay, now let's start writing. Our next category or next type of fractions are sixth one, equivalent fractions. That means fractions represent the same part of a whole even if they seem to be different are known as equivalent fractions. Hope you understood it. Got it? Yes. Now let's start writing. Okay. Start writing neatly. So sixth one, our sixth type of fraction is equivalent fraction. Or let's write plural, equivalent fractions, equivalent fractions. Okay, equivalent fractions. Equivalent fractions are the fractions having same value. Equivalent fractions, write down, okay. Okay, 1 minute, pardon. Okay, let's write. Equivalent fractions. Equivalent fractions are the fractions having same value. Equivalent fractions are the fractions having same value even if they look different. Even if they look different. Got the concept? Yes. Equivalent fractions are the fractions having same value even if they look different. These fractions represent the same part of a whole. These fractions represent the same part of a whole. These fractions represent the same part of a whole. These fractions represent the same part of a whole. Got it? Yes. Now let's do one example. Please draw the the rectangle that have been drawn earlier. Okay, example. Please draw 3 rectangles of the same size. Please draw neatly with ruler and pencil. You can do that. Do neatly with the ruler and pencil. Draw 3 rectangles of same size. And in the first one, the rectangle has been divided into 4 equal parts. And above name it as figure 1. And second one as figure 2. And third one as figure 3. Yes, okay. Now the first rectangle has been divided into 4 equal parts. The second rectangle has been divided into 2 equal parts. And the third rectangle has been divided into 8 equal parts. You please draw neatly with ruler and using ruler and pencil. Okay. Now let's represent the shaded portion. Please shade the half portion of the given rectangles. Neatly, shade it neatly, okay. Please neatly shade the half portion of the given rectangle. Okay. Given rectangles. Here also please shade. Yes, okay. Now we know what is the fractions corresponding to these rectangles. Okay. Here in the first figure, what is the fraction corresponding to not rectangles, corresponding to the shaded portion? In the first figure, what is the fraction corresponding to the shaded portion? Yes, we know out of 4, 2 are shaded, so 2 by 4. And in the second figure, out of 2, 1 is shaded, so 1 by 2, isn't it? In the third figure, out of 8, how many are shaded? 4 are shaded, 4 by 8, isn't it? Drawn up to this. Now, how can how can the conclusion be written? How can we write the conclusion? Yes, from the figures given above, it is clear that I think no more explanation, much explanation is not, explanations are not needed. So that directly we can write the conclusion, isn't it? Can we write? Yes, okay, right. From the figures given above, from the figures given above, from the figures given above, it is clear that fractions 2 by 4, 1 by 2, and the third one is what? Yes, 4 by 8 represent the same part of a whole. Represent the same part of the given rectangle. That is enough. Of the given rectangle. Same part of the given rectangle. So these fractions are equivalent fractions. So these fractions are equivalent. So these fractions are equivalent fractions, and we can equate them. Equate them means we can represent them using the equal to sign, and hence we can equate them, and hence we can equate them. Okay, so how can we equate them? Yes, write them. We can represent them using the equal to sign, isn't it? They are equal. That means our first fraction is what? Yes, 2 by 4. That is 2 by 4 is equal to second fraction is what? 1 by 2. And what is the third fraction? 4 by 8. Means they are equivalent fractions. That means they are equal. But for comparing or verifying equivalent fractions, we can't draw the figures like this and all. So for verifying or for checking whether the given fractions are equivalent or not, two methods are there. So let's discuss them one by one. So write down next notes. In this section, very important notes are there. That are the two methods for verifying equivalent fractions. Okay, write down notes. Equivalent fractions can be equivalent fractions can be verified in equivalent fractions can be verified in two different ways. Two different ways. What is the meaning of equivalent fractions can be verified? What is meant by this? Yes, on seeing certain fractions, we can check whether they are equivalent or not. This can be done by two different ways. First one is by finding the lowest form. By finding the lowest form. We have learned how to find out this lowest form in our cancellation method session, isn't it? If this method can be used if two or more. This will be explained in the coming class. You please write down it today. It will be explained in detail in the coming session. By finding the lowest form, if two or more fractions are given. If two or more fractions are given, we can compare we can check whether they are equivalent or not by using the lowest form method, or by finding the first method is by finding the lowest form of those fractions, and second method is second one. These methods will be explained in the coming session. Now please write it down. Okay, second method is known as cross multiplication method, or by cross multiplication. By cross multiplication. By cross multiplication. This method can be applied if only two fractions are given. If only two fractions are given. If only two fractions are given. So, for checking whether the given fractions are equivalent or not, there exists two methods. First one is by finding the lowest form. This method can be applied if any number of fractions are given. Two or more means if any number of fractions are given and we have to compare whether they are equivalent or not, we can use the lowest form method. But if only two fractions are given, it is easy to use the cross multiplication method. Understood? If more than two fractions are given, or if any number of fractions are given, we can use the lowest form method, and if only two fractions are given, it is easy to use the cross multiplication method. These methods will be discussed in detail in the coming sessions. So hope you understood the concepts well. Learn it today itself. Okay, be up to date. Thank you. Have a nice